feel very proud to be associated to the 3D printing industry. Obviously, Jim and I have known each other for a few years. We've acquired considerable exposure across a range of industries because of the 3D printing and the additive manufacturing industry. But I'll come to that in a little while. So, what is the hype? I don't mean hype in a bad way. I mean, what is the hype? Look around us. There's thousands of people here today learning about the industry, obviously hoping to see new technologies, etc. So, a few years ago, people had very high expectations about 3D printing. They thought it was going to change the world, etc. And then obviously a little while after that, people realized it wasn't going to happen quite as quickly as that. But I think things are changing. It's quite clear that we've got an unprecedented awareness of 3D printing at the moment. Even the layman knows about 3D printing. You know, kids, school teachers, all sorts. You know, I've been approached by strangers, oh, tell me about the 3D printing industry. And I've sort of taken it on board to help people learn about these things. Okay, so the culture's changed. You know, there's now websites that you can upload your files to and get stuff shipped to you via 3D printing bureaus. Yeah, there's all sorts of competitions, aerospace companies and software companies putting calls out to the public to see what people's suggestions are how to solve things. And okay, I'll be quick. Levels of investment in the technology are at an all-time high. We've got some very large sums of money coming from Europe to support the research into aerospace, etc., which obviously I think reflects people's aspirations for the industry. Okay, so what's the use? 3D printing and additive can be used for all sorts of things. I think one of the things that we see these days is increased productivity. There's quite a few stands you'll go to where you'll see not products having been 3D printed, but jigs, fixtures and fittings, things that speed up manufacturing. Things like prototype tooling. I'm sure some of you will have seen 3D printing materials being used to injection mold into, or conformal cooling systems in tooling. It's really quite interesting. And obviously, there's a whole level of increased design complexity in these things. But that also opens up lots of new opportunities, and I'm sure that's why a lot of you are here. Okay, so what are the limitations? Well, we all know, after you look at the machines, these machines don't do everything, but they do some things very well. The costs seem to be one of the prohibitive factors for lots of people. But then look around, we see thousands, hundreds of machines where the costs are coming right down, the capabilities, etc. In the past, the materials were a limitation. You could only build in a few metal powders, etc. This is changing. The materials weren't particularly stable under UV. This is changing. In the past, rapid prototyping and additive manufacture was a distinct technology. You used it to replicate your other things, etc. But my view is that this is changing considerably. These previous cost models of where your break-even points come and the point at which you should decide whether or not to go to full tooling, etc. This cost model kind of worked for about the past 10 or 15 years, but my view is that this actually now needs to be revised. Okay, previous cost models need revising because we now have machines with larger working envelopes. We have machines that can build things quicker, multiple parts, nested parts, etc. And the market has very much determined this. People have seen that additive it's there as an industry to provide us with things. And I think basically people going to industry to say, right, well, this is interesting, but can you make it do this? Can you modify it to do this? So the market has definitely helped shape the industry. Okay, so yeah, improved build quality, resolution, speed, etc. We've had our industrial revolution. We've had our technological revolution. I believe we're on the brink of a materials revolution. Obviously, people are developing materials now that will almost defy that we know already. And I think it's really exciting times for us now. Obviously, the build technologies have advanced, the materials technologies have advanced, and I think now, combine that with a really furtive sort of attitude of engineers and designers such as yourselves, and we don't know what this is going to bring. Okay, so some credits here. Thank you very much for the image from Renishaw. This is a bracket built in titanium. The previous bracket this replaced looked nothing like this. This gave weight savings, obviously material savings in manufacture, etc. So we can make things lighter using additive. Obviously, yeah, we can manage the material properties and we can make elastomeric prints, etc. So we've got exotic combinations, functional materials, etc. And like I say, these aren't just driven by the manufacturers and the industry itself. This is actually driven by people requesting information and developments from the material manufacturers. One of the things that, to me, is going to bring, or is bringing, additive manufacturing forwards is the streamlining of post-processing. Many of us will be familiar with what parts look like when they've come off a sintering machine or a metal powder bed machine. If we can start to take out some of the processes like re-registration of that component from this process to that process, then all of a sudden we start to be able to make real savings from those combining of technologies. Additive now, when combined with other technologies, this is when it really starts to bring about some of the benefits. I don't know if any of you are familiar with hyperjoining from Airbus. This is a novel fastening technology where it's using the mechanical properties of the forms of the additive and embedding them into pre-preg composites and then curing that, and you get the best of both worlds. It's a fantastic process. Another thing that's moving the industry forwards, obviously, is the traceability of materials. For aerospace to adopt additive manufactured components, etc., obviously, it's not just the component that needs verification, so too does the material. Obviously, some of you will be involved in aerospace. You fully understand the traceability required for all aspects in that for quality control purposes. This is happening. We have FDM materials that now are being sourced right back to the pellet so that can be traced literally back to the initial source of manufacture. Obviously, we've got hybrid manufacture. I think it was Delcam I saw, where they had a very, very posh tool repair process, where they would be taking a tool that's got some damage, welding it, then machining it, and additive manufacture repairs in there, etc. So the bridge between additive and other machining technologies brings the possibilities together. Okay, so there's quite clearly benefits from this that can't be ignored. I'm sure that's why we're all here. As we can see, we've got vast increases in functionality of components. We can make components that are not only structural, but cooling as well. Instead of having an item over here and an item over here that needs to be assembled to perform a function, all of a sudden we can combine objects, materials and processes to give us this vast increase in functional capability. Obviously, we've got shortened developmental life cycles. And this graph here, when I talked about the previous cost models, if you think about the holding cost of having an inventory of components, if you no longer have to tool up, spend vast sums on tooling, but you also don't have to have a vast inventory of products, then all of a sudden, that business model that makes additive the manufacture a prospect, all of a sudden that changes drastically, especially when you may want to iterate that design a few times in the future, therefore having inventory implications, etc. What's the bottom line? Potential for cost reduction, and that's probably why many, many people are here. Rotite technology, which is kind of why I'm here, is a technology that was developed using additive technology. Now, my invention was a classic 3 a.m, inspirational eureka moment. I then went into work and had a discussion with a colleague at 9 o'clock in the morning. By 9:30, I was 3D modeling it. By lunchtime, we'd printed one out, but it didn't work. So we modeled it again, we evaluated it, we modeled it again, and by 5 o'clock in the afternoon, we had something in our hands that was unbelievable. And we looked at it and went, right, crikey, this is unbelievable. Now, we've gone on to patent protect our technology in 34 countries, 35 countries, and all of that was based upon a moment of inspiration with the ability to 3D print something. Had we not had that ability to 3D print something there and then, I wouldn't be stood here today. Quite simply, the idea would still be sat on the shelf. So, in fact, Jim, I said this at my last presentation. Somebody once said to me, "You go into TCT? TCT, what's that?" I said, "Time compression technologies." They said, "What's that?" I said, "It's this." being able to do stuff in record time. So that's why I'm here, and that's what I believe TCT is. So it's continuously developing field of technology where we can see every year there's new people here at the show, new technologies, new approaches, new solutions to things. Again, there's new demands on industry. As soon as you skilled engineers get 3D prints in your hands and you realise what you're capable of, then all of a sudden you expect more from it. So it's very exciting times, I think, in terms of people having even higher expectations than ever before. I think this is one of the areas where this industry is going to take probably the most traction at all. And that is when you start to integrate it upstream into other processes. I've mentioned about 3D printed tooling for injection molding, etc. And I'm sure some of you all wander around and see some of the composite molding techniques derived from 3D printing, etc. When you stop seeing it as a replication tool and you start to see it as an integral tool to the developmental process, then you've actually got to be quite careful where you see this technology, because before you know it, you're actually undertaking a part or a process or a stage in your development that you probably don't need to, because there's a pretty good chance that these technologies can work themselves up that stream. So, okay, here's one example I was talking about. Okay, what do we have? This is a soluble core in an FDM machine being used to make a composite manifold. So there's lots of emerging markets for this technology. Obviously, the major drivers that led this were obviously the automotive, aerospace industries, etc. Now, these aren't the only markets for additive manufacturing these days. My view is that there's literally thousands of opportunities across a range of industries where if you give one man one material and one machine, and another man the same material and the same machine, they could go off to two entirely different ends of the markets that are available and come back with totally valid uses for that technology. So I think it's quite interesting. Obviously, if you take a walk around the show here today, you'll see all sorts of novel materials. You'll see conductive FDM polymers, you'll see high temperature photopolymers, all sorts of things. And given the range of all of these different technologies, all the different machines, and our heightened expectations about what's available and what the opportunities are, I think there's a new rule book for design and engineering. And it's kind of being written right here, right now. We are the people using these technologies. We are the people learning from the new technologies that we see. And I think, I think we're going to be astounded by the things that we see from this technology. Okay. One of the things that really interests me about this industry is the fact that we've learnt how to control X, Y, and Z really quite accurately. We've also learnt how to stick various things out the end of this, whatever this item is. Now, I have colleagues who are specialists in inkjet technology. It's the same technology as a lot of the printers that are out here. Obviously, we now have very, very, very precise control of X, Y, and Z. We also have very, very precise control of those materials, how they're processed, but also what those materials do in their resultant form. I wouldn't be surprised if in 2 years' time you heard of an aerospace company who'd printed their entire fuselage via FDM technology and then put a functional coating on the top of it that was photovoltaic. That's one example of where I see, these things are totally and utterly believable. You've got precise control over the materials, precise control over the build technology. That brings about a whole set of opportunities that I don't think we can even conceive those today. So I'm very proud to be associated to this industry. We've gained considerable exposure because of the sort of transcendental nature of this industry. Obviously, you look around, there's people from Formula One, people from nuclear, people from product, people from design, jewellery, etc. That gives you an idea of just how transcendent this industry is. So, yeah, a number of years ago, we were a small startup business with some 3D prints. But because we had some 3D prints that were really good quality, we then went around and saw lots of people in different industries. We're now very lucky to be working with a number of different aerospace companies, automotive companies and research institutes. And yeah, that pretty much most of that success can be pinned on the fact that the 3D printing industry has such trade events like this. So, okay, what does it do? Additive manufacturing technologies, they're here, they're accelerating not just the technologies, but the possibilities, which in my eyes, they're completely limitless.